Good morning, ladies and gentlemen. A warm welcome to the second day of 6G India 2023, the first conference, in fact, I was told in Asia, not in India, it is in Asia. May I request all of you to please take your seats. We are going to start the program. And those who are on the exhibition hall, please ask them to join us here. So we have a fantastic session here, although early morning we are starting a little late because I've been told there is a big traffic on the way, but still we've been able to reach here. Today's chief guest, we have General Pant, Dr. Rajesh Pant, who is the National Cyber Security Coordinator, Prime Minister's Office, Government of India. Along with, we have the Chair, Saurabh Mittal, Vice President, Network R&D, Bharti Airtel. Amit Kumar Anand, CTO Enterprise Solution, Nokia. Chief and Senior Director of Product Management, Cineverse. Sadaf Sidikil, GM Industry Marketing, Keysight Technologies. Mahesh Baswaranju, Marketing Segment Manager, Wireless Communication, Road and Source, and Vikas Dikshit, Reliance Jio. Before we start the session, may I request our chief guest, General Pant, to light the lamp along with other speakers to start the conference program. Sir.
वक्रतुण्ड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा.
May I request all of you to please join the dais, sir. General Pant, Mittal, and all the speakers, please join the dais. Once again, good morning, ladies and gentlemen. As our Prime Minister has put on our target for the 6G vision, which is called BHARAT 6G Vision 2030. And we are well in advance, almost 6.5 years from now, as I've been hearing since morning that 5G was in hurry-burry, as you must have all heard, and we could not put all the ecosystem together. And yesterday also the wireless advisor and all the people were saying that 6G should be good to go with all the ecosystem together with the investment and the support of Government of India. So without taking much of a time of teaching you what is 6G, which I am not an expert. We have an expert here. And I request our chief guest, General Pant, who is the National Cyber Coordinator from the Prime Minister's Office, to address the gathering. Sir.
Good morning, ladies and gentlemen. Let me first compliment Mr. Shashidharan and his team for organizing this 6G India International event and exhibition. It just shows that India is now firmly established as an international telecom player, and we are thinking ahead. And I'm glad to see that we've learned the lessons of 5G, where we missed the bus in most of the standards. Earlier, I remember our delegations that used to go for 3GPP were in single digits. Just one or two people at times from DOT used to go, whereas from some of our neighbors close by, there used to be almost 100 people, mostly from the industry, that used to attend those sessions, and that's how they got the repertoires and the standards, etc. So we've learned those lessons. Now we have a number of ITS officers posted in some of the working groups in IT also. And I must compliment the Ministry of Communications for this excellent document they've come out with, the Bharat 6G Vision document. How many have read this Bharat 6G Vision? Okay, 4 or 5. I request all of you who are interested in this subject to at least go through the document. It will show you what those 6 task forces have done, what is the direction that the Government of India intends to take, and you know, the entire ecosystem, and I was just discussing with him about the systems view of 6G. All I wish to say is that when we were talking initially about 5G, we said that 5G is a road. And why we called it a road is because in India especially, and I think most part of the world as well, there used to be, and there are still a large number of villages which do not have a road connecting the villages. And the moment that road was built, it was not only the transport that benefited. I mean, the whole society benefited. Children could go to schools, better schools, the trade flourished, the society flourished, people were meeting, hospitals, healthcare, every sector improved because of that road, that one road. Which is why when 5G came, we said it's not a telecom system. The IoT and the M2M and all the other ecosystem that it is going to create, it is the road. And if 5G is the road, then I think 6G is the highway. It is going to transform, it is going to be 100 times faster speed, the precision, the ultra low latency, the M2M, the IoT, the connectivity with the satellites at low, medium and geostationary orbits. There is a vast scope of use cases in 6G. We went to Japan some years back, and they were telling us that they're already doing research on the human era of communications, as they called it. Because they said presently you're only transmitting 2 senses, the sight and the sound. There are 3 other senses, the touch, smell, and this thing also. So they said that they're also thinking how to transmit the other 3 senses. So the world of telecom is limitless like the space. There is much more to be done. But coming back to 6G, I think this is the right time for us for practicing and testing and discussing our use cases. About 127 patents we've already got in 6G. And as I say, India is on a roll. And we must complement all the initiatives that are being taken by various ministries and by the private sector. I must especially compliment in coming together and creating this ecosystem. And with these words, let me once again compliment, and I wish the exhibition and the event all success. Thank you very much. Jai Hind.
Thank you, General Pant, for the addressing the gathering. Now we will start the session. So I hand over the mic to the chair, which is Saurabh Mittal, who is the Vice President, Network R&D, Bharti Airtel, to start the session. Thank you.
Thank you, Shashi. I think this is such an excellent initiative, and welcome, ladies and gentlemen, to the second day of the 6G India conference. I think it's absolute pleasure and an honor for me, to be in company of all the august speakers and this, house over here. Thank you, Lieutenant General Dr. Pant. I think the analogy of the road to the telecom network is so apt, right? And we have seen the networks and lives getting transformed with all the, telecom evolution which has happened in last 2.5 decades in India. I think I'll also share the quote from Robin Sharma. He said that things are created twice, first in mind and then in reality. And what is really happening in India today is, I think, is a great testimony of this particular fact. The idea that India can lead the 6G journey, I think, is such a game-changer mind shift. I've been part of this telecom journey for the last 2.5 decades. And I've seen the kind of following that we used to do in the 2G world, to now talking about leading the world. I think, most of you would have seen the movie Inception. I think this idea, when you start thinking, it has a different kind of an approach. And all the compliments to the government of India, I think, for making this mind shift into the mind of the telecom industry over here. And I would say that the Indian telecom industry has also risen to the task. I think it was not about 8 months ago, probably 8 kilometers from here in Pragati Maidan, when Honorable Prime Minister, announced the launch of 5G. And now today, we are amongst the fastest rollout probably in the world, the largest and the fastest. It's already, maybe 120K plus base stations deployed across different networks. Maybe speaking lower volume, the numbers probably will be higher, because every day, hundreds and thousands of base stations are getting lit up. So, but is this movement to rejoice? We also, I think I would say from the industry perspective, General Pant, we spoke about the ORAN that we have been doing. At Airtel, I can speak, for example, we have taken leadership positions in the lot of standardization work or the industrialization of the standardization work, so as to say. We hosted the ORAN Plug Fest, the Global Plug Fest, twice at Airtel in last 2-3 years. But is this these are moments to celebrate, but is this enough? In fact, I also recall what Robert Frost would have said, right? There are promises to keep and miles to go before I sleep. And why do I say that? Because in these conferences only, we have spoken about the promise of 5G, right? We talked about the use cases of 5G. We talked about the 5G monetization. I think we were debating, right? In the boardrooms, every company would have gone about and saying that, okay, this is what probably makes the business case. But is that the reality? I would say that this is something which all of us have to continue to work towards. We probably for the first time have a situation where networks have evolved faster than what our colleagues in the IT industries are coming out with, right? They always were complaining earlier, network is not probably, behaving as better as they would have expected to deliver out. Now we have a situation where there is a network, but then the use cases have to evolve. But I'm sure we'll hear more about these cases in this session. Similarly, everybody talks about network as a sensor, right? And that's something which is very, very fundamentally important to make the world smarter, living smarter, more efficient, right? We have seen the sensors like, smart meters, the POS machines, the connected cars, home automation. These things are coming. These are becoming mainstay of the network. But what's the reality? The reality is these are running on 4G. Even actually, majorly, many of these are running still on 2G actually. Why is that? I think as an industry, we need to think over this. One of the major reasons is the cost, right? The 5G devices by itself are far more expensive. If you start to make every sensor on a 5G network, I think the kind of cost which it takes is humongous. I think there are many things happening. Probably we'll also hear about that in the sessions. Then, of course, there is the issue of roaming, right? IoT roaming is something, there continues to be challenged. There's not a very good method of having 5G roaming across the world. That's something which is still evolving. So these are the issues I would say, that's very important from a 5G perspective. I think in this session, we will have talk on 5G monetization, we'll have discussion and talk on the IoT, as well as IoT roaming. I think, so I'm quite excited to hear all about that part. But then, obviously, the big question, right? why 6G, right? I mean, if there are so many issues on 5G, why we are talking about the 6G? In fact, my daughter yesterday, I mean, I told her I'm going to, the 6G conference. She was saying, come on, right? Few months ago, you were talking about 5G, now you're talking about 6G. Why 6G? I think then, I probably would like to recall how 5G helped 4G. The improvements or the efficiency of 4G that we see today is partly due to what the work item on 5G started to happen. If you look at the concepts like massive MIMO, if you look at things like CUPS architecture, which actually really helped improve the 4G latency, these are all things which actually came from the 5G work items. What you did in 5G, I think, and there was a great work done within 3GPP and GMN, these concepts actually got evolved and adopted into the 4G world. So I believe that the 6G work item will really improve and make 5G more advanced, right? So that's something which is going to be far more really, really interesting. And the next thing which I say is that, often it comes out, right? What's the new in 6G, right? There is already 5G, what's the 6G which is going to really add to the entire ecosystem, user experience, all that part. Then I was thinking, and then I came with another acronym, right? Which probably will help you, easily recall, right, what 6G is going to really add to this. And the answer is very simple. Answer is the word 6 itself, S-I-X. The S, the first letter, stands for sustainability. I think we have seen that, right? The telecom networks can be huge consumers of electricity, right? There is a huge carbon footprint which comes around. The 6G, then, from a vision statement perspective, is really talking about making it far more sustainable, right? Making it the footprint, carbon footprint, far more lower, so that you can run on, if you look at devices, the battery life should be far, far longer. The energy consumption per bit is expected to go down dramatically. Then comes the I. I is inclusion. The inclusion is multidimensional over here. The inclusion could mean, for example, global coverage, right? And you can think of this inclusion, global coverage, in slightly different sense, right? The 5G are terrestrial networks. This is meant for land. The 6G is going to be across all types of terrains, right? It's not land, it's about air, it's about sea. And how you do it is, there's going to be much closer collaboration between what is there as the terrestrial network and the satellite networks, and maybe new other HAPS networks, for example, the LEO satellites which are there, the HAPS which are there, they can all collaborate to give a global service coverage across the world, wherever you are, right? On land, sea, or in the sky. And why sky? For example, that's the third dimension of inclusion, which is saying that it is from now not just human, but human to cobots, robots, drones, so all those kind of systems coming together. The third dimension, of course, or the fourth dimension of this I, or inclusion, is the merger of the human world and the virtual world, right? I think, so that's the, I would say the simple I probably we can take forward, right? As a new kind of a capability which comes into picture. And then X. Now what is Mr. X? Answer is also, what is Mr. X, right? Today, in our networks, we become, the security and privacy is a big concern, right? I don't know, there's been articles, and I personally experienced in last 3-4 days, there has been a lot of WhatsApp call coming from overseas, probably talking about remote work items. Now, if you look at from a security perspective, the people are trying to exploit probably which was given as a user convenience. So this X over here, the Mr. X, stands for the trustworthiness in the network, right? The security and trustworthiness. So I would say these three additional things which are there, which is sustainability, inclusion, and trustworthiness. These are the three additional dimensions which are being brought by 6G to what was done in the 5G. The 5G, we all had this beautiful triangle which ITUT created, and all of us have been talking in past few years, which is EMBB, the first vertical The vertex, the second vertex being the URLCC, ultra reliable connectivity, and then the massive machine type communications. So these three were the network-centric view of the network capabilities which are going to come around. Now with 6G, at least from a vision statement, the three new dimensions have been added: the sustainability, inclusion, and the trustworthiness, which I would say are the business indicators of what the network should deliver, right? So this is something which is very powerful. What happens is that with every G, there is a new unconstrained thinking. Because if you are in 4G, you are thinking about 4G, we generally get constrained as engineers, technocrats, that, this is how the standards have been written. Probably we just do incremental thinking. When 5G came, or now in the 5G, when we are talking about 6G, and we are in the vision formation stage for till 2024, the standardization bodies, industry alliances are actually looking to come out with what is it's supposed to be really delivering, right? And then there is going to be all the work items which will follow in the standardization. I think this is the time for the unconstrained thinking. We don't need to get bogged down by what is today's networks. I think we really need to think creatively on that front. So I think that's where the 6G is going to really help accelerate. And it's time for Indian ecosystem. We have like the wonderful talent. I would say a lot of development center for many of the companies which are the leaders in this space is actually based out of India. So there's no reason why we shouldn't really be able to lead this. Whether it is software, hardware, silicon, I think there is work items happening in all the domains. And thank you, Shashidharanji, for organizing this very timely session. And I'm personally very excited to listen to all the speakers. We'll have talks on the 5G monetization, IoT, and then we'll delve into the 6G, what's on the verge of 6G. Then we have a discussion or a talk on the what's happening on the Open RAN, which will help accelerate the 6G related parts. So personally very excited and look forward to this session. We'll start with Mr. Amit Anand from Nokia. Thank you.
One moment.
Shall we start? So, good morning and warm welcome to the dignitaries on the dais and in the August House. Thank you very much for being here, and Bharat Exhibition and Shashidharanji for inviting us, giving us the opportunity to share our views that how private wireless, talking about 5G, we are talking about 6G now, but how private wireless can help industries in the future and how they can unleash the potential of Industry 4.0. So before we move into this, let's understand that where are we? As on date, we are on the cusp of Industry 4.0, and the world is moving towards digitization through the new technological advances. And these advances are enabling, apart from the IT industry, the asset-heavy industries to get their assets connected and then get into data-driven, become zero-touch automation, and transform the machines and the human, they're interacting together. So if we have to unlock the potential of Industry 4.0 and the industrial IoTs, we need to get our assets connected and then get the data analyzed, bring the insights, and then do the analytics part of it and improve our efficiencies, performance, and reduce our costs. But the irony as on date we talk about There's a research done by Nokia and our partner consultant TBR that 70%, 74% of the data is not collected in the industries as on date. So, what Industry 4.0 is going to deliver? So if we talk about certain parameters on which that Industry 4.0 is going to help industries in all vertical segments in terms of enhancing efficiencies, increase the agility. You have the flexibility to move the assets, how you can monetize your assets on a real-time basis, configure them. Then decision making, again, what kind of production need to change at what time frame, how to improve my OEEs. And most important thing, we are talking of ESG these days, which talks about even the worker safety, apart from the environment, social and governance, where the worker safety is most important for improving the productivity. And last but not least, sustainability, where we need to see that how our assets are being utilized with less power consumptions, less carbon footprint, and we make value out of these products. And on top of it, we need to take care of all the investment which industry has already done over the last 2, 3, 4 decades. At how we can connect them and take the data, control them, do the predictive analytics, and on top of it, take care of their requirement that they can do 24/7 operation sustainably without fail. So this is the deliverable of Industry 4.0 revolution which is being talked about. Let us see the cycle of Industry 4.0 transformation. If we start from from cycle 0 to till date what we are looking, so I'll just go to the transformation cycle, that first we need to connect the assets, then understand what is the kind of data coming over here, how we can convert the data into insights, do the predictive part of it, bring the automation into action, and then we complete the cycle of Industry 4.0. And all this is helped with the help of Industry 4.0 enablers, which we talk about over here in terms of robotics, in terms of cloud, edge clouds, with different IoT sensors and applications, and then driven by the private wireless network, which is industry grade. Yes, we have wireless technologies in place, but the kind of industry grade private wireless networks which delivers the requirement for Industry 4.0 unlocking the potential over here. And believe me, this is again a study by McKinsey and Nokia that there are 14 million industries globally. As we see the distribution across different verticals, they are looking for this transformation journey. But the needs of each and every industry and the segment is totally different. And each has to be addressed as per their specific requirement and specific use cases. So if we see in summary, what kind of use cases or the industry is asking for, which private wireless networks to support in their environment. So if we talk about, without going much into all the vertical segments, starting from the power sector, utility sector, to the mining, to the airports, to the port, shipping, automobile, manufacturing, there are different use cases. And we see on a horizontal level, around more than 50 to 60% use cases are mostly common in all the industry verticals. Remaining 30-40% are basically specific to this use case of particular industry over here. So this is a requirement which industries are asking from us globally, world over, and India is not far away from that. As we speak, we have been engaging, I have been personally engaging more than 100% industry verticals over here, the CIOs, the IT teams, who are looking to do the digital transformation, how they can bring their assets, people, and monetize their assets, and improve the OEE part of their organization. Before we get into what private wireless networks are, let us just see the ingredients of the private wireless networks. So, three main components. One is the spectrum, where we have through auction, we have our CSP partners who are custodian of the spectrum. Then second is basically the equipments which are portable, which have kind of zero-touch automation was there employed and deployed in the field. And after, on top of it, the enablers. If we talk about these enablers, these are the main thing which connects the industry machines, which are old ones. We are not talking of the new ones. Even the new laptops are not 5G ready. But when we have to connect to the existing machines, think of any industrial or automobile manufacturing areas, how we can, with the help of these enablers, we can connect those machines and take out the important data, on a real-time basis, and then do the predictive analysis and do our work. In that sense, we can create the complete environment for us, which is worker-friendly, which improves our cost, do the improvement of OEs. And all this is done with a complete dedicated on-prem environments fully secure in the control of an enterprises. So that's the basically basic ingredients of any private wireless network deployed at industry level. And as we speak, whether it is 4.9G or 5G, and tomorrow going to the 6G, Nokia is making it happen globally and in India. How? This is the kind of reference we are carrying as on date global. We have close to 600 private wireless network across different vertical industries for port, mining, manufacturing, automobiles, even in the airports, then on the armed forces as well. So these are different references which are there, and we are providing across the globe this kind of networks. And on top of it, we support the full end-to-end portfolio, starting from radio to the services to the core deployment, edge applications, segmented application for segmented vertical use cases. Whether we talk about port, mining, because we know that for these industries, the machines which are there, they require certain industrial connectors also, so that we can take the traffic out of from here, and how we need to, encapsulate that, analyze that. So these kind of things are also required. It is not just simple Wi-Fi plug and play that you just connect it and everything is done. So this kind of portfolio is being developed by Nokia over here. And this is done again with the three different partners which are very much ecosystem players. That one is the service providers, second is the industrial body ecosystem players, the various OEMs, manufacturer of different machines for different industry verticals. They are very important for us to get partnered, and they need to tell us that what kind of traffic and what kind of data is taken out from them, so that the predictive analytics, the maintenance, and other things can be done for these machines. And third is the system integrator and consulting, because we need to get into the 14 million kind of industry rolled out and the transformation. It can't be done by a single or two or three entities. We need lot of partners in different domains, different expertise level, so we can see the potential available for over here. And this is till now, it was not theory. Practically, apart from global, we have deployed these use cases, this private wireless network in Chennai, where we are manufacturing radios from 2G to 5G and exporting to the rest of the world. And we have implemented use cases in the domain of automation, massive IoT, analytics, and digitization. And if I just try to highlight over here, that in case of automation, we are running AGVs, AIVs, collaborative robots, the telepresence robots over here for the helping our manufacturing process in our Chennai factory. In case of IoTs, we are talking of LoRa, Zigbee-based solutions, carry forward backhaul through the private wireless network, which enables the real-time help to the shop floor guys. The indoor positioning solution. Indoor positioning solution, it gives the accuracy of our assets lying in a 55,000 square meter area kind of shop floor within a vicinity of 1 meter. So that's the kind of accuracy we are developing in the indoor positioning solutions. Again, with the help of industrial connectors, the predictive analytics which we are able to do for machines, or robots, AGVs and AIVs, it helps us see how we have to streamline our SMT lines. So these are the things which have really helped us. In Chennai, we have deployed more than 100 use cases on the private wireless network. Digital twin, like we were talking yesterday a lot about digital twin. The complete assets of our factory is, we can see on a single TV screen, where they are lying, they are ideal, or they are working condition, if they got faulted, when it got into faulted condition, when it is going to get rectified, which department is taking care of. So all those things are being taken care in a single TV screen. We can see the digital twin of complete factory in terms of assets. So this is the kind of use cases we have deployed, and they are real in word. Some of the use cases has been deployed by people in different industry verticals as a journey of Industry 4.0 revolution. And also we couldn't do in one day. So we will just show you the journey of this. We started with hardware automation, then we started putting AGV, AIV, robotics automation, then different use cases came into play. So it's a journey which we have followed over a period of 3, 4, 5 years, where we have come to this place that we are running seamless 4G network. We did trial 5G network when the trial spectrum was offered to us for the industry people. And after that, now these are use cases are running on 4.9G and also tested on 5G. So we are talking of use cases. They are available, they are working. It is the decision which the CIOs, the IT team has to take, that what kind of use case they want to develop or deploy for their particular industries. So I just covered this. in a manufacturing environment. Basically, I'm trying to cover three major industry over here right now: vertical industry, manufacturing, automotive, ports, and mining, which are the ones which are driving this globally. Also, we have seen kind of use cases or the deployment of private wireless, because the connectivity for these areas are very minimal in those places. So in the manufacturing environment, I just covered that how we divide this industry or a manufacturing plant into 4 different categories, and then what kind of use cases are planned, what kind of use cases can be seen from them, starting from the training, virtual reality-based training, to the worker safety, to the digital twin of campus, as well as asset monetization. So name a use case or or as per the need, the software is available, which can be dovetailed and can be backhauled with the private wireless network. And we can see the things on our mobile handset, what is the production on a daily basis or hourly basis. Moving to the mining, which is very important, and they are the most hungry for connectivity, because in the remote areas, there's no connectivity available from any of the CSP or live or the fiber part of out there. So, but the mining industry is driven by 3 main parameters, if we see: the health and safety, the productivity, and the efficiency, which means cost per ton. And they are looking for the digitization and automation of their operations, and so many use cases they are looking to deploy, that how this can help them, digitize and automate their operations. They're talking of, remote operation of their drilling haulage systems, maintain asset tracking, worker safety. All the use cases they are looking for these things. If I just dwell into the use case required for the mining, whether we talk of underground mining or on the open pit mining, so many use cases have been listed and people have deployed it. As we speak today, Nokia has deployed more than 80 mines, private wireless network, both combined of open pit and underground mines, where everybody has taken a different journey of deploying of use cases as per their needs, whether they do want remote operations, or they want the worker safety first, or they want surveillance. So these use cases people are seeing as per their need, and they're deploying it in the mining area. And in India, similar things are happening, which we have been talking to major miners over here, and they're looking for it, how to get it deployed. And they were waiting for the 5G spectrum, which can deliver a lot of data, video, and other things. So the things are moving in this direction as we speak. And some analytical reports, which from McKinsey, from the miners, as well as the equipment OEMs in the mining industry, we can see the kind of savings they are expected to reach when they do the digitization and automation of any mine location. So these are the numbers which we are talking in terms of saving in dollar value, saving of fuel, which means the sustainability, then how they can increase the production, asset monitoring. All those aspects are taken care when you go into digitization and automation journey of any industry. So these are the particular things which we will talk about in mines. Moving to port, they are not too far away. When we go to the port remote area, whether we go to JNPT, Pipavav, or Mundra, or anywhere else, the connectivity is very poor. And we see the daily footfall of 5,000 to 7,000 people over there. So the connectivity for a normal human being is very difficult. Forget about for the cranes, for the assets, truck moving, and when it's moving, where it is idling, and all the things. So these are the use cases which people are looking for push-to-talk, push-to-video communication, drone surveillance, mission-critical connectivity for these guys. How to track my assets, how to track and do the connectivity when the ship is coming. How can I make my berth ready for that? So how can make the more moves from the cranes and all. So these are the use cases which people have deployed globally. And if I give you the data that what kind of savings they have achieved, it is humongous in nature. Even by just deploying, you can see that how they can improve the berth movement. When the ship is, how much time is required to offload a ship when it comes to the berth. So they're kind of increasing the number of movement. They're able to turnaround time from 10 hours, they can reduce about 4 hours. So these are the kind of various benefits they can give. How much TEU they can increase on an annual basis? 10% increment, which is huge in numbers. So without going much into all the details, that what kind of efficiency which have been achieved by globally, and these are not the Nokia numbers, so these are the published numbers from different port guys, that what kind of efficiency they have achieved in different deployments, whether we talk of US terminals or German terminals or in Africa or Latin market. So similar things, operators, the terminal operators over here, they are trying to replicate the things in our Indian ports over here. As we talk about the global APM guys, Maersk guys, or the other port terminal guys, they're looking for such kind of implementation over here. And as we speak, we have done some trials along with Airtel that how the digitization journey can be started for these guys. So just to summarize, this is all from my side, but just to summarize in a very brief video of 2-3 minutes, where you will see that apart from these industries, what additional can be done for other industries, so that you can have a quick glance of the things.
When it comes to transporting materials, autonomous mobile robots really deliver. The coverage, reliability, and other features of private wireless give these next generation of intelligent AGVs the context awareness they need to avoid obstacles. They can use plant data to stay updated on production changes, and data from cameras and sensors can improve collaboration between themselves and workers. A digital twin puts a data-rich model of an object or process in your hands so you can understand and act smarter and faster. You can improve OEE by reducing downtime and improving performance. The aircraft turnaround process can be a big source of inefficiency. Pervasive private wireless connectivity can change that, giving real-time data, increasing automation, and helping move planes, baggage, and people faster and more accurately. Safety is another big concern. Using wireless CCTV cameras that reduce blind spots, PTZ cameras on common use in emergency vehicles, even body cams with push-to-video, airports can get faster, detailed operational awareness of the entire site, and zoom responders to emergencies in no time. With 360-degree situational awareness, you can get the widest possible picture of safety and sustainability. Connect machinery, vehicles, staff, and IoT sensors for remote health and safety monitoring. Get data from sensors, cameras, drones, and more. And use video feed analytics to remove workers from hazard. Autonomous vehicles push all the right buttons for productivity, efficiency, and safety. Power autonomous drilling and hauling for 24/7 operations. Use AI and predictive alerts to avoid obstacles while monitoring remote automated operations in real time. Private wireless covers virtually every corner of the terminal with mobile broadband, passing data between vehicles, cranes, and employees. This improves yard operations in many ways, from empowering better operational control and worker safety to enabling real-time monitoring of reefers with instant alarm data for rapid response. A data-rich private wireless network also provides sweeping situational awareness from drones, sensors, and other devices. Highly reliable voice connectivity keeps communications clear, while push-to-video and wearable sensors boost effectiveness and employee well-being. And throughput can be improved with real-time workflow optimization enabled by advanced analytics. Private wireless connectivity empowers distribution automation for grid applications that improve reliability, outage and voltage management, and distributed renewables integration, enable fan convergence for better cost and flexibility, and extend proven IP MPLS WAN service, security, and management to critical devices at grid edge, optimizing performance and simplifying operations. Pervasive wireless connectivity lets you rapidly access required data for predictive maintenance that reduces unexpected asset failures, lost productivity, and premature replacement of assets. Nokia industrial-grade private wireless, powering the new age of industry from now to next. Nokia.
So let's unlock the potential of 5G till we reach to the 6G. Thank you. Happy to be here and answer any questions.
Thank you so much, Amit. It is always very exciting to look at the potential of 5G. I just wish that the CIOs or the IT organizations write down the checks to put up all the 5G networks and bring up the productivity. Anyway, now I would like to call upon Mr. Chip Stevens, Senior Director of Product Management, Cineverse.
Good morning, everybody. Thank you very much for having me. I'm thrilled to be here. I'm thrilled to be in India and coming to talk to you about this. I'm going to have a little bit of a different take than what you've heard over the last 2 days. The one thing that's been very constant, though, that we've talked about, that all the different panels have talked about, and my colleague from Nokia did a very nice job of setting me up, so I appreciate that, is monetization, right? So we've talked about the networks, you've talked about the standards, and what is the one subject that keeps coming up over and over and over again? Great, how do I make money, right? We've spent all this money, we've built all these networks, we've done all these things. Where is this increase in revenue? Where is this money coming from? And so I'll start off with a little bit of an opinion piece on this, in that, you know, when 5G came around, right, in terms of monetizing it, we thought about it the same way we thought about how did we do 4G, how did we do 3G, how did we do 2G, right? It's the same standards, it's the same way of exchanging records that we've been doing for 30 years, right? So even if you think about it from a consumer standpoint, and the consumer is sitting there going from 4G to 5G, and if you were to ask the average non-telco person, right, what's the big deal with 5G? What would they say? It's faster. So so the problem is, partially, right, is we didn't educate our consumer base enough to allow them to think about, you know, well, maybe I should have to pay more to get more, right? Maybe I should have to do more or to consume all these great services. They got used to, well, you know, of course it should be faster. Of course I should get more. Of course it should do better. And so, you know, as we're thinking about this, as this is a 6G conference, and we're thinking about it, right? So you've got 6.5 years to consider this. And, you know, one thing I would encourage you as I kind of walk through this, the thing I would encourage you is to be thinking about that. And it's great to come up with these technical network, you know, solutions, right? It's great to have these standards. But as you're going through that process, the thing you want to be thinking about is not only what are the use cases, but how am I going to monetize those use cases, right? Where are we going to make money on that? It can't just be another iteration of faster, better, cooler stuff, right? So with that, we'll jump into this. So what does this look like? So I thought it would be a good idea to kind of start with, you know, and I entitled this yesterday and today, tomorrow, right? I could have easily said today and tomorrow. But really, we're straddling those lines of where are we and where do we want to go, right? So we're kind of going from, you know, a 3G, 4G world, and M2M, machine-to-machine stuff, tap records to exchange, right? Retail pricing, right? One of the panelists yesterday, I thought, spelled it out perfectly, in that the way carriers, I think, have always thought about this monetization is very much a B2C, right? How are my consumers going to do it, and how do I charge my consumer? Well, when we look forward, you know, what is that going to look like? What are we going to go to? That needs to change, right? Like I said, he started to go down that path, and I was a little, I'm like, uh-oh, he's going to steal a big part of my presentation, but I thought it was a very good lead-in, because I think it's very, very important that you have to change your thought process about who is it that's consuming your stuff? Who is it that you're partnering with? How do I charge for these things? You know, who am I going to interact with, right? So instead of doing retail pricing, you probably need to start thinking about wholesale pricing, right? You think about private networks, right? You think about going from very simple pricing models. Today it's, you know, I have so much data that costs so much money, here's your bill, right? It's very simple. And so what that doesn't allow you to do, being so simple, it does not allow you to then monetize that very well, does it? Because with 5G, you got lots of cool things you could do, right? We could do network slicing. We could identify traffic based on the type of traffic it is. So not all traffic is created equal. And what we have seen over and over again from the analysts is that enterprises are willing to pay premium prices to get very specific services delivered. But today, you know, I would say that this is where we're in that straddling area. Today, you're not able to do that, right? Because it's so simple. So one of the things you'll hear me talk over and over again is you need to be able to identify that traffic. What does that look like? And then who is consuming it at the end? Maybe you need to think about that differently. Now, the good thing is what's coming, or what's here now, it's not even coming, it's here now, is that there's a new standard for exchanging records, and that's the BCE that I refer to, the billing and charging evolution. So as we were rolling out all the cool 5G network stuff, also from a billing and charging perspective, we've come forward. We've given much more flexibility in what we charge for. How do we charge for it? How do I identify it? And that's critical, right? Because if you don't have that sort of standard method of being able to monetize these things, then you're going to keep having that same conversation over and over again, right? When you're going to have to go explain to your CFO, well, here, you know, hey, we're once again going to drop our prices because everybody else is dropping their prices. Right, that's a bad place to be. And it's because we can't identify and we can't monetize those things well enough. So you've seen lots of stats, you've seen lots of numbers, and I thought this is a really interesting way to look at this, and that this is, you know, where do we think the IoT traffic? So you're going to hear a lot more about IoT from our other panelists, but just to give you an idea of where this is and how IoT is being consumed today, is that, you know, as a carrier in your network, is all these IoT devices, almost 70% of them, over 70% of them, are permanent roamers onto your network. So what does that mean? That means somebody else's SIM card is sitting on your network in some IoT device, and it's transmitting very small bits of information over predetermined amounts of time, right? Well, the problem with that is that's generating tons and tons of traffic, and you know what you're not able to do? Monetize it, right? Because again, it's so small, you're talking KBs of packets, right? So again, that's a very retail way of looking at it. So what we have going forward is a very wholesale way of looking at it, right? So what we have is there's a lot of business challenges, right? Things are changing. We all know that. That's why we're here, right? The networks are changing. Technologies are changing. Who your business partners are probably going to change. What are your use cases? Everyone keeps talking about that. What's my use case? What's my killer app, right? What are my usage patterns? Who's using it? Where are they using it? What are the commercial models? Old commercial models, I'm telling you, is not going to cut it, right? And so this creates lots of challenges for us. You know, there's friction in that business process. So as much as, again, as we want to think of 5G, we want to think of 6G as a purely network thing, the more you can involve your business partners and say, hey, this is what's possible, now let's figure out how do we go monetize it, right? If you were to go have that conversation right now, you'd probably get a lot of blank stares. You know, how do we exchange, you know, it's difficult because you have lots of different formats coming in. If you want to go, as you know, the great video we just looked at, if you want to go do private wireless, you're probably going to start having a lot more different kinds of records that are going to come in, or different formats that are going to come in, right? That's extra overhead, that's extra work, right? The workflows that go through this, how do I then initialize that, right? How do I get those into the marketplace? How do I get those into my network so I know what's going on? Right? How do I handle disputes? Again, these are uncomfortable topics that you really need to think about of, you know, it's all well and good to roll out these new services, but if you're not thinking of these things, right? How do I know what business logic's been applied? How do I know what's the right business logic? You don't want to find out 6 months down the road, right? Holy cow, I mistariffed that, right? Or, oh, wait, I was only supposed to give them, you know, 100 gig pipe, and I've given them way more than that. And so they've been using my network for free for 6 months. So when we look at this, right, what you want to be looking at going forward is being able to fix all these. And the great thing is that this exists in the market today. This is not fantasy. This is not, hey, we're working on the standards. Hey, it'll be available in you know, when 6G comes out. A lot of the things that will fix these things are available today, right? So consensus processing, doing more validation and compliance up front, right? Making your workflows very uniform, so it doesn't matter kind of who the partner is or what you're getting in. We can make that all very uniform today. What does reconciliation look like, right? Again, these are very important business things. How do I make sure the right people are getting paid for what they've delivered? You know, how do I get more visibility online as to what's happening, right? How do I get my money faster, right? Your CFO will love you when you can say, hey, look, I can cut this down from 30 days to hours or days, right? Or 60 days or 90 days. How many of you have like more than 90-day payment terms on things? If you could drop that down to being able to do it on a daily, weekly basis, your CFO is going to love you for that. So this is meant to be a bit of a provocative kind of leading question. What does this mean, right? What does all this mean? You're probably wondering, you know, is this a massive opportunity for me? Is that how you're viewing it? Or is this the perfect storm that's coming your way and you're about to get flooded and you have no idea what to do? So the good thing is that, you know, hopefully we can educate you a little bit, give you some more ideas, give you some more tools as to what can be done. But this is kind of what you need to start thinking about is what does this look like, right? As 5G goes to 5GSA, as 5GSA goes to 6G. You know, learn from those mistakes. Don't create a network and then go, oh, well, let me go see how I'm going to go monetize it. You know, the tools exist today to monetize it. So as you're getting there to 6G, as you're rolling these things out, as you're rolling private networks out, as this avalanche of IoT stuff is coming, you want to be able to make sure that you can identify it and monetize it. So again, a bit of a leading question here. So I want to, you know, I come at this from a very roaming kind of centric basis. Now the interesting thing is that our business is changing, right? Or that business is changing. That sort of carrier to carrier, you know, B2C exchanging that traffic is really changing, right? And the reason we had to come up with a new standard is that TAP is the old kind of the B2C, it's been around for 30 years standard of how do we exchange records. And the problem is that it was rigid. There was no flexibility to it at all, right? So every time a new thing came out and you wanted to try and somehow, well, how do I get my money out of either my carrier partner or even better, my enterprise partners, there was no way to do it. It was all very just X times Y equals Z, right? That's it. And so the other problem is your legacy billing models are very impractical. We'll talk about roaming IoT. I think one of the panels is going to talk about that. Again, it's very impractical, right? How do I get that? How do I make it so that I'm actually charging, right? Here's the holy grail we all want to talk about. How do I charge for what's actually being used on my network, right? Isn't that what you really want? Isn't that going to make you the hero to your CFO? And so today, what one of our problems is that from an IoT perspective is those devices, those things are consuming your network resources, and you are probably not collecting any money on it. So that's an uncomfortable truth, right? And it's something that, you know, we in the industry don't like to talk about these things. We don't want those out in the open, right? You know, the last thing you want to do is, you know, again, go walk into a C-suite and say, oh, well, yeah, all that. They're like, hey, why is our data usage up and we're not making any more money? You don't want to have that uncomfortable conversation, right? So the time is now to start thinking about it, right? 5G is, you know, we're starting to see the first kind of 5GSA, you know, actual up live roaming networks coming to be right now. So you've not missed the boat. You're not behind the curve at all. So these are things that you want to start thinking about. How do I want to charge for those services? Can I charge for those services? Who are my customers going to be? And the great thing about this is that by creating a monetization strategy now, it's really going to give you that opportunity to do that, right? And if you're a network operator, or if you deal with network operators, the biggest thing here is that, you know, think of 4G, right? When 4G kind of came and then 5G happened behind it, what happened? You went from controlling your consumer, controlling that customer, to now it's just, you know, and again, I'm willing to start ducking if you want to throw things at me, but they became a bit of a dumb pipe, right? Consumers, what did they do? What's the first thing they did? Oh, great, I'm going to go get WhatsApp. I don't know, why send a text message? I get all the data I can consume for free, right? Or you know, they're paying for it, but in essence, it's for free. So that's the first thing they did. I'm just going to go over the top of you. Now, the good thing that's happening, though, from that perspective, is that consumers are now realizing, well, they have app fatigue, right? I don't want to have to control, 20 different things on my phone to do the 20 different things that I want to do. So who's the one person sitting there that has that ability to not only control that interaction, but also then start, again, like I said, start thinking about what are you doing from an enterprise perspective? How do you go after those mining customers, right? How do you go after airports? How do I monetize that? How do I work with the health industry to do telehealth, right? How do I work with call centers, right, to provide these services and to be able to get paid for them? Again, enterprises are willing to pay for these things if you're providing this good service for them, right? The second bullet there is to me what probably one of the most important things here. You have to be able to identify and categorize and monetize these untapped revenue streams. And again, the good news is the standards exist, the ability exists to be able to do that, right? You have to understand what's going on in your network. That's the other thing. What does that traffic look like? Who's using it? What are they using it for? Look at those use cases, right? One of the biggest things that we see that I think over the next several years that you're going to see is how is private wireless used? If you think about it, private wireless is, and again, there's no offense to my Nokia friends, but everything is an island, right? So what is the big thing everybody wants, right? What are you've come to expect? Seamless, interconnected connectivity, right? I want to be able to take my phone, go to where I want to go and use my phone, and I don't want to have to think about it, right? Think to the bad old days of roaming, right? Whoever my carrier was, as soon as I went to I came off their network, what happened? Call dropped, I got to call my friend back, right? Or you'd tell them, hey, call me and then hang up and I'll call you back so you don't have to pay for the call, right? So, as you're thinking about those things, and what that leads you to is implementing wholesale charging. You've got to start thinking B2B. That's where the money is, right? Your consumers are your consumers, right? It's great to have hundreds of millions of subscribers. It's awesome. But their expectation is always going to be, I want more, I want it cheaper, and I want you to give me more services for that. And I don't want to pay for it, right? I talk to operators all over the world, and they all say the same thing, right? That's what their consumers are telling them. And so you can either keep going down that path, or you can change the conversation, right? I remember an old quote of, I'll summarize it basically, that said, if the story you're telling doesn't work, change the story, right? Quit thinking that this is a B2C thing. It is, but it isn't. They're not going to be the ones cutting you the checks, at least not the checks your CFO is going to want to see, right? And the other thing is you've heard this over and over again, you've got to be able to automate these processes. How do I make this quicker? How do I make this more seamless? How do I remove friction out of that process? And so, because I'm a roaming guy, I always like to talk a little bit about this, right? But this is, if you're a carrier or you're dealing with carriers and you're worried about this, these are the things you need to think about, right? I've said it over and over again. Add that flexibility that doesn't exist today. But it is available. It's not that you can't or you shouldn't. You do need to, and it exists now, right? How are you going to deal with all those network technologies that are coming? How are you going to deal with all those use cases that are coming? How are you going to deal with, the machine learning and all of those things, AR, VR, all those things? What are you going to do when 6G happens? Are you still going to be trying to wedge things into a consumer model? No, it's impractical. So I'll leave you with this. This is my final thing, and again, if you don't take anything else out of this, I would highly, highly encourage you to memorize these 4 things. If you want to monetize your traffic correctly and properly, so that you're getting paid for all those resources you've consumed in creating your networks, whether it's a 5G network, whether it's a 6G network. 4 things. You need to identify that traffic, right? Who's using it? And then you need to categorize that traffic. What is it being used for? And then once you've done that, then what you need to start doing is, how do I simulate those charging models? Well, if I charge differently, what does that look like? Is it really more money, or am I making it worse for my customers, right? Then negotiate. This is the thing, probably it's a different sort of way of thinking about it. But once you know how your network's being used, and you know how you want to monetize it, and you know what's being done, then you can go have a good negotiation with whoever your user is. If it's your consumers, then go talk to them about that. Hey, look, if you want to stream Netflix, or if you want to stream, you know, YouTube videos, or whatever it is you want, well, maybe you should have to pay a different price for that. Or I want more bandwidth, or I want faster. Fine, if it's okay to have faster, but faster is going to cost you. Today, you can't separate that out and charge for that. So once you've done those things, then we finally get to the subject of my conversation, which is monetizing, right? Then you can start to make profitable business decisions about how your network and how your data is being used. So with that, thank you again. This has been fantastic for me. I look forward to hearing the rest of my colleagues talk, and thank you all very much for your time today.
From Keysight. Thank you.
Okay, so very good morning to all of you and a very warm welcome once again. So we had some amazing sessions, and in fact yesterday also, I'm not sure if all of you were there, but there were some amazing talks around like 5G, how exactly it is shaping up, and then the road towards 6G. So firstly, I believe my best wishes to the organizers for organizing this very first 6G conference, because I think although we might see this as a bit early from a standard perspective, but I think in today's world, we have to be very aggressive in terms of technology, because the time to all these technology windows, it's getting very shorter day by day. And while 5G was a very different standard maybe few years back when it started shaping up and the way it was envisioned, so it was very different from the earlier standards. The previous standards, the thinking was more towards calls and data in terms of limitations and strictly, I would say, sticking to your phones. But the way 5G was thought upon and it was drafted, so now as since morning also we are hearing very interesting use cases. We heard about Industry 4.0, so that is like one of the key use case which we will see moving forward with 5G and beyond. And likewise, we are talking about variety of use cases, so be it its implication in healthcare segment, in automotive segment, in education, and a lot of these things like including IoT and all. So because of that, we see 5G as a bit different standard, and this will continue with 6G and beyond. Now, very interestingly, like when our Honorable Prime Minister rolled out 5G about few months back in the month of October, I believe. So this is happening at a very fast pace, meaning the way it is getting rolled out. But again, as we heard in some of the talks, that still we have to see the full usage of 5G. We also have to really look upon the monetization aspects, which is very true, because in any of these technology, one key aspect is on the technical front, but the second key aspect is also on the ROI front. So the investments, what we are putting in, be it in terms of designs, be it in terms of setting up the infrastructure, setting up services, setting up networks and all. So we really have to look into the ROI also. Now we as an organization, so I'm coming from Keysight Technologies, and we work very closely with the standard bodies, with various segments, be it, I would say, telecom operators, service providers, chipset manufacturers, then academic research and all. So we all have been sort of talking about how exactly we can look into the ROI front also, and that's one of the key aspects also for today. So in maybe next 5 or 10 minutes, I'll try to talk about one interesting aspect. I'm not sure if some of you have heard about this. So maybe I'll just do a quick check with the raise of your hands. How many of you have heard about this term, red cap? Okay, few of you. So maybe, yeah, so maybe next 5 to 10 minutes, probably you will get some insights about this thing, and then what exactly it means and how exactly we can look into very interesting use case over here also. Okay, so this is basically what we say as a light version, 5G NR light version, or the reduced capacity. So in most of the sessions, most of the presentations, we sometimes highlight about the various upper side advantages of 5G, like the three key pillars, if you see, enhanced mobile broadband, or massive communication, or ultra reliable low latency. So these are really good words, and the way 5G is drafted, we are really looking about the upper limits and all. But sometimes we also have to scale it back to achieve maximum advantage from this particular technology. Because for sure, 5G will help in Industry 4.0 in private networks, which is really required these days. But then we are also talking about some basic or mid-tier categories like IoT, wearables, automation, which is as of now limited to some fixed technologies, but we can definitely make use of 5G in those categories also. So this is exactly the direction for this particular light version, what is being called as 5G NR light version, or reduced capacity, or REDCap, which was sort of included in release 17. And now in release 18, we will see more progress around this. So typically, if you look the use cases over here, we are talking about things like industrial sensors, we are talking about wearables and surveillance, wherein these sort of use cases don't require like all these max capabilities or max features which 5G can provide. But definitely if we just scale it down, so probably we will have wider use cases. And then it will also bring down the design cost, it will bring down the operational cost, and then also from the investment perspective, I think we should be able to achieve good returns for some of these use cases. So the cost reduction strategies, as I mentioned, probably we are designing in a way that we are reducing on some of these capabilities, either in terms of, so this particular slide talks about that. Like if we look into these use cases, sensors, wearables, or surveillance, we are not really talking about very high data rates, which typically you hear in 5G, NR, or maybe in other bands also. We are talking about maybe subtle data rates which can really help in achieving all these capabilities. So we are talking about, let's say, up to maybe 150 megabits per second. We are also not talking about very tight, precise latency figures and all, but then again, as I mentioned, this is really a very broad-based use case, broad-based industry, which can help in making 5G as one of the use case over here also. Okay, now, how exactly this is shaping up in terms of benefits, and while we are trying to scale down some of the capabilities, are there any trade-offs? So definitely, in terms of benefits, as I mentioned, we are sort of scaling down any of these things which you might have heard about with respect to 5G. So 5G, we often hear about massive MIMO, for example. We hear about 256 QAM modulation scheme and all. We talk about full duplex, TDD, FDD. So here it's exactly, we are sort of limiting all these parameters, as I mentioned about data rates. We are sort of limiting the MIMO capabilities. We are sort of limiting the modulation scheme which is being drafted. And the second column, if you see, so this is the biggest advantage, that while we are trying to scale it down, the biggest beneficiary is in terms of we can really reduce the cost over here. Okay. Now trade-offs, so again, I won't say as a disadvantage over here. Trade-offs meaning definitely in terms of data rates, there are certain limitations, but end of the day, it's up to the designers or providers that they can again think of scaling it up as required. Okay, so we heard about these three triangles. So one of my co-panelists mentioned about that when release 15 or 16 or 17 was drafted, and the three vertical pillars, what we talk about is enhanced mobile broadband, massive machine communication, or ultra reliable low latency. So we are just trying to add another capability over here, or another triangle over here, which can really sort of good implications on wide variety of use cases, meaning the IoT, the smart IoT, what we say. And again, smart IoT, even from an Indian perspective, Indian segments perspective, you see, we are talking about smart cities, for example, or smart industries, for example. So again, a very strong implication over here, which is having a very tight cost reduction, And then from a ROI perspective, a very good feature over here. So one key thing to highlight over here, now this is something which is not just limited to FR1 band, because some of you might think that while we are talking about 5G and NR, light and all, is it really up to like sub-6, sub-7 gigahertz? So the story is we are also thinking beyond that, typically taking it to FR2 band also. And here again, you will see a lot of technologies, what we say as cellular IoT, getting pulled into these bands also. So this is exactly the specifications, what is being captured in release 17 and release 18. As I mentioned, probably we will have more progress in terms of 5G NR light version in the red cap capabilities, and probably this will be interesting to see how exactly this mid-tier use cases will also take advantage of 5G, which is like evolving. And also the idea is, while we all are here in 6G conference, probably some of you might be thinking why we are so much talking about 5G. So the idea is 5G, it's not yet done. Right now, while it is getting rolled out, we are more focusing on FR1 band, but probably moving forward, we will see more work around millimeter wave or FR2 bands, and that is when probably it will also give a good road towards 6G, because 6G is like we are just talking about some higher data rates, some wider bandwidths, and probably some additional use cases, which can provide us more immersive experience. So with this, I'll just highlight one last slide from organization perspective. So we are very much associated with the standard bodies, and we are also trying to think how exactly, probably with some of these capabilities, we can also look into the ROI perspective. Test being an investment, we are also thinking upon on how each of these different use cases, they really don't have to always look upon the higher investments or higher set of equipments. Probably they can also minimize their investments with respect to design, test, and measurement, and end of the day get benefit with respect to the ROI. So any of you, like if you are associated with Red Cap or probably thinking about 6G also, so we do have a strong presence over there, and we are there in the next hall. So you are most welcome to talk to us, discuss us, and I'll be happy to take any questions. With this, I'll end my session. Thank you so much.
Thank you so much, Mr. Sadaf Siddiqui. Right? This was quite interesting. The red cap concept is certainly worthwhile to look at, though I'm sure that I think just as an input from an operator community, right, the benchmark from a cost improvement perspective is not going to be what is the today's 5G, but it should be, I mean, from what is today in the 4G domain, what's available. And we'll certainly look forward to what really comes out from the standardization and how the entire ecosystem player really take this forward, because that's a real challenge to solve. Also, thank you for sticking to the time. I now invite Mr. Mahesh Baswaraju from Rhodes and Schwartz.
Okay, good morning, ladies and gentlemen, and welcome to this 6G India 2023. My name is Mahesh Baswaraju. I'm the Market Segment Manager for Wireless Communications in Rhodes and Schwartz. So today I have two aspects to focus on. One is the 6G research area, the strong possible candidates for 6G, and then the second aspect would be about how Rhodes and Schwartz is adding value or contributing to these early R&D projects through our solutions. So that would be the agenda for my short session today. And going into the 6G research areas, so here we have the different candidates. So for example, whenever we move from one generation to the next generation, obviously we are talking about new waveforms, new multiple access schemes, new channel coding schemes, and then how we can bring in efficiency into the communication system. And as with 4G to 5G, we had the introduction of massive MIMO, and now this is going to turn more into ultra massive MIMO, as you see here. And then the network topologies are also very important, where This will evolve with the distributed computing, and then full duplex communication. We are aiming at full duplex communication over a single carrier. And then, as many of my co-panelists also highlighted, security and trustworthiness right from the design, from the start. Yeah? So these are some of the features we expect from the next generation wireless communication technology. And then we have also the photonics, visible light communication. So in the simplest form, it is like a light emitting diode, which is transmitting light with different intensities to convey, like say, for example, this is the information carrier now, visible light. And on the receiving end, we have the photonic diode, which understands these different intensities of the light to decode the zeros and ones. So visible light as an information carrier. So these are some of the candidates, which I'm not going to go into details because of the time restrictions, but I'll pick some strong candidates, like as we have seen from yesterday and also from today, like the terahertz communication, joint communication and sensing, artificial intelligence and machine learning, and then we have the reconfigurable intelligent surfaces. So what these features or candidates are and how we are supporting the industry in realizing these technological components. Yeah? So firstly, starting with the terahertz communication and also the FR3. So here, if we look at what are the frequencies we are talking about for 6G, so terahertz by definition from ITU and IEEE means frequencies from 300 gigahertz to 3 terahertz, but most of the publications we are now referring to anything above the 100 gigahertz up to 10 terahertz as terahertz communication. So if you look at this spectrum, the entire spectrum, we have different bands. So starting from D band, which is starting from 110 gigahertz to 170 gigahertz, and then following we have the G band, H band, and also recently in the recent WRC meeting, ITU has identified 4 candidate frequencies in the range from 275 gigahertz to 450 gigahertz, which are possible candidates for the next generation wireless communication. Yeah? So this is what we refer to when we are talking about terahertz communication. The first candidate would be here the D band, which is the 110 to 170 gigahertz, which most of the industries and academia are focusing on, to learn about how the channel responds, how the channel responds when we are using the D band for communication, wireless communication. So then, what are we trying to address with the sub-terahertz or terahertz communication is, as we have seen, the shift from feature phones to smartphones, and now towards, when we are moving towards the next generation of wireless communication, we'll see more and more gadgets and devices which are convergence, which is a convergence of augmented reality and virtual reality called as extended reality. So even in our booth, MWC booth, Mobile World Congress 2023, the booth we put up in Barcelona, we had no smartphones, but an AR, VR headset from Motorola for demonstrations this time. And these kind of devices, they have different requirements. So they need higher data rates. Say, for example, if you need to project an holographic avatar in a mobile device kind of a form factor, then you need nearly 0.5 terabits per second data rate. Yeah? And also now latency, for example, is no longer just the round trip time of a packet, but it's motion to photon latency. So, so that you don't get sickness feeling when you are using these gadgets. Yeah? We are moving in this direction. And also we are moving from, say, for example, the touch-based man-machine interfacing to face recognition to now, say, for example, gestures. So wherein the end user could be communicating with this device using gestures. And academia, they have identified that what could this be leading to, what might be the next. So here, these gadgets are going to use phase array antennas, and with a required range of about 1.5 meter, and also resolution. meaning to say high resolution. The current technology offers resolution in the range of centimeters. Now with the next generation of devices, we need resolutions of the order of millimeter. Yeah? And how can we achieve this? A resolution is with wider bandwidths, higher data rates. That means we have to move to a higher frequency, say for example, 340 gigahertz, terahertz range. So that is the motivation behind the terahertz being used for wireless communication. And now some of our customers are already working in this direction, designing the RFICs, the antenna arrays, which are using D-band for communication, and also wider bandwidths, MIMO, and higher order modulation scheme for achieving, say for example, 6.2 gigabits per second end-to-end communication. And our customers are working, meaning we, and so are we, providing solutions. So any communication system, we have to have the basics right, meaning to say the components used should support these high frequencies, wider bandwidth. And for component characterization, we need solutions like the network analyzer, vector network analyzer, the instrumentation, what you see here, and the ZNA family from Rohde & Schwarz. This network analyzer is being extended with a converter to facilitate research work or component characterization up to 170 gigahertz. And this is on the vector network analysis. How about the generation and analysis of a modulated signal? So here we have the well-known combo for the industry, the SMW200A and the FSW family, the vector signal generator and the vector signal analyzer, which in a standalone format can go up to 67 gigahertz. Now this can be extended with the front ends, the FE170 series, to reach up to 170 gigahertz to facilitate those initial R&D projects in D-band. So this is about network analysis, generators, analyzers. So at such high frequencies, we are talking about over-the-air testing, which means you need chambers. And here we have the chamber portfolio, development ongoing on the chamber portfolio also to support or facilitate D-band measurements. So here in the picture, you see the patented chamber portfolio from Rohde & Schwarz, chamber on wheels. So here, the feed antennas and the reflector and the turntable, all of those are getting reworked or revamped in order to facilitate those early testbed activities. So 6G, nevertheless, it will take advantage of the existing FR1, FR2. And also, this terahertz is going to work on something called the unofficial FR3, termed the FR3, frequency range 3, which is nothing but the frequency range from 7.125 gigahertz up to 24.25 gigahertz. So as the last speaker yesterday, Brigadier, mentioned about this FR3, it's also kind of is going to act as an anchor when you are using sub-terahertz or terahertz communication. And there are challenges with this band, but this is also kind of an interested spectrum space which the industry is looking into, the FR3, yeah? Especially between the 10 to 15 gigahertz frequency range. So that was in short about the terahertz communication. Let's move on to the joint communication and sensing. So this is through, again, many speakers have highlighted about the applications or use cases around joint communication and sensing. So this is the convergence of the communication system and the sensing. So some of the use cases could be gesture detection and control, and also yesterday, Mr. Robert, the one who was talking on behalf of government of Tamil Nadu, he was highlighting about these cars using, say for example, when they are coming around in the blind spot, the network would sense if there is a possible collision happening, then it will be the car will be alerted about it. So similar use cases. So here, what we are trying to do is a sensing-assisted communication. We are trying to come out with a sensing-assisted communication system in order to achieve efficiency in, say, for example, about the beamforming, the channel status indication, interference mitigation, and so on. So all the while we had these transmitters transmitting signals, and then we had the receivers on the other end receiving the signals, but we were not paying so much attention about the additional data sets, like say, how is the signal being reflected, obstructed on the way, and also about the medium with which through which it is transmitted. Now we kind of try to learn from these data sets, additional data sets, to improve the efficiency of the communication system itself. Challenges, of course, research challenges, what frequencies to use, bandwidths to use, what kind of waveforms, these are existing, but now we are kind of going in the direction of sensing-assisted communication. So in order to realize this in a lab, what would you need? A communication system, which we already know, the 3G, 4G, and 5G, and then sensing. This is also a known thing, like say radar-centric design, where we are using chirp signals for transmission or as an information carrier. So now it's converging of these two worlds called as joint communication and sensing, or integrated communication and sensing. Yeah? So here, for example, what would you need if you want to realize such a test bed in a lab? So you have the base station transmitting the signal. On the other end, you have the UEs, which are receiving. So, and then we have the blockers or the reflectors, which is this object here. And we have a communication channel here. In addition, when there is a reflector which comes into picture, so here we have a separate sensor channel which comes into picture again. And then now we have, in addition, the interference. So what would be required if we have to realize this? So there are different KPIs to monitor the communication channel. Say, for example, some of the KPIs are throughput, voice quality, video quality, RF performance like EVM, error vector magnitude, the power, the spectrum. And likewise for sensor channel, we have different KPIs, which could be the detection, the accuracy, the resolution of the sensing channel itself. And then to realize this in a lab, we need, say, for example, some of the attributes here. For the reflector would be the speed, the distance, and the angle of arrival of the signals, and so on. And to realize this in a lab, you would need a signal generation and analysis, and in addition, the object emulation. So this is this green box, what you see here. In the middle, the radar target reflector. So again, it falls back to the same instrumentation which I showed you in the previous slide for terahertz communication, the SMW, the FSW, and then the object emulator is that box called REG 800. Yeah? So we did this demonstration already a year back in IEEE 5G Summit Dresden, and then during the MWC 2023, we had this same setup, and this setup won the GTI award in MWC. And moving next to artificial intelligence and machine learning. So here we are coming from a test and measurement company. We are a test and measurement company, and here I would like to explain about how we are using machine learning and artificial intelligence in order to achieve efficiency. Say, for example, machine learning based on neural networks. So here we take an example or a use case about how to achieve the optimum settings on a generator and analyzer to have the best possible error vector magnitude. So here I'm talking about neural network which can take the inputs like the power level, the peak to average power ratio, the bandwidth, the frequency, and I expect the output layer to produce values for reference level, the attenuation, and the automatic gain control, for example, say. So what can we achieve with this? Say, for example, when we are using this combo, the SMW and FSW combo, so here I can have a push button wherein I just say optimize the EVM settings. So then when I push in the button, I have the optimum settings recalled or set by the training set itself in order to have the best EVM possible. So this was about the use case where we are using artificial intelligence and machine learning. So going forward in wireless communications, we can use similar ideas to achieve the best CSI, the channel status indication feedback and enhancements the beam management, that is an area where you could use machine learning and artificial intelligence, and also to improve the positioning accuracy. So these are possible areas where artificial intelligence and machine learning can play can play a key role. And when you go to 6G, so right now if you see the block diagrams here, each of these blocks can use machine learning or can use machine learning to train, to come up with a training model which is optimized. And this will be the first step. And then use machine learning to replace some of these blocks to increase the efficiency. And then the third phase could be to use it as a native. Say, for example, artificial intelligence becomes native for a 6G communication system. Yeah? So these are the different phases. So individual blocks, and then maybe the receiver chain could be the first one to get these machine learning and artificial intelligence being used for replacing or optimizing some of these blocks, and then as a system as a whole, which could be the phase 3. So adoption of machine learning and artificial intelligence into 6G, future wireless communication systems. So the phase 1, here we are focusing on the easy, low-hanging fruits, like say, for example, optimizing the front end. Research work has already started back in 2020, and here I have cited some examples from IEEE. So with that, we come to the last topic, which is about the reconfigurable intelligent surface. Yeah? Reconfigurable intelligent surface, what it is. So all the while, for any given communication system, we have been focusing on the transmission stream, which is the S of T, in order to have a best reception at the receiver. We assume the channel response is constant. It's something which we cannot do anything about. Yeah? So now is the time where we are changing this. So meaning to say, instead of adapting the transmission scheme to the target channel, we are now trying to adapt the channel to maximize the reception quality. So which means we are trying to play around with this channel response to have the best reception possible. So yesterday, Mr. Robert was also talking about this could be any material, a reflective material, maybe the paint was his example. I would say maybe the window panes. So if you look at this hotel in which we are, so this hotel has many window panes, and these window panes can be those reflective surfaces when they are equipped with controllable parameters. Controllable parameters, what could it be? Say, for example, we have the impedance, tuning the impedance. When there is an incident beam onto the window panes, the reflected signal, if I can tune the impedance or maybe the phase shifters so that the reflected beam can go in a certain direction, I have control on the channel. So I can steer the beam in a direction which I want to. So this is how I'm trying to influence the channel so as to achieve a higher efficiency. Yeah? Again, here, when it comes to test and measurement perspective, what would be required? So for a RISC, that is reconfigurable intelligent surface, to measure if the surface is reflecting the signal in a desired direction. So this measurement would obviously happen inside a chamber. And this is a screenshot of the chamber. And what we are trying to monitor is the magnitude distribution and the phase distribution, the beam patterns, a simple example. Yeah? And here, the chamber which you saw earlier is now being extended with side chambers which can be attached. So you have a much larger space inside the chamber. And also, you can have the feeds and the probes at different locations, at different angles, to measure whether the reflected or reconfigurable intelligent surface is reflecting the signal in the desired direction, the beams in the desired direction. So we have this for test labs or test beds who are interested to do this work. We have solutions already today. Yeah? So some of the projects where Roden Schwarz is participating or is contributing to. So yesterday we had Eva talking from Telefonica, Germany. So she was mentioning about 250 million contribution from the company, from the government, where they're setting up test labs working on these topics. So here you can see some of those projects, like 6G ANA, the code name is Lighthouse Project, and likewise the different projects which are backed by the government, the German government. So BMBF is the German government who is the sponsor, and you can see the partners and also our contribution, what we are trying to provide to these test beds where the early R&D is happening. So here, say for example, we are working on all this space which I mentioned, AI, ML. So here we are trying to do the proof of concept together with these partners, and then the joint communication and sensing. Here we are providing all the solutions or test concept inclusive of radar, because we are also providing solutions for the radar, aerospace and defense community, and likewise the different projects you can see here. Yeah, and lastly, we are also engaging together with the academia and the industry. So here you can see some of the examples, the 4 test labs which are backed by the German government, and also the 6G flagship forum which is backed by Finnish government, and also the industry alliance like ITU, NGMN, Next Generation Alliance, and so on. We are working together with all these partners. And yeah, this is about timeline. I think I agree with all the co-panelists' view that 5G is not a sprint, it's a marathon. And this year it would be special because still LTE is the primary player when it comes to the number of subscription. And this year, 5G would overtake the number of LTE subscribers. And there is still a lot of potential on 5G. And this we will see. 5G is not going to go away. But the 3GPP release 18, we already have some foundational topics like AI, ML, extended reality, which is for the 5G, but is laying the foundation for the future wireless communication system, which is the 6G. And timeline-wise, I would agree with all the speakers who have talked about the timelines yesterday and today, that 2030 would be the time when we would see some first deployments, 6G deployments, and first 6G devices. And this will be decided what frequencies will be used in WRC 27 in the year 2027, somewhere around there. And yeah, the standardization, here you can see when it would be complete, maybe by 2030. Yeah. With this, I come to the end of my presentation, and I would like to say R&S is actively engaging with all the industry partners in different phases of fundamental research, providing expertise in test and measurement, making ideas real. So this was my part, and I would like to thank you for your attention. Thank you very much.
Thank you so much, Mr. Mahesh. I think we really got a glimpse of what to expect in 6G. Next session, I think is very close to me. I mean, this is from Mr. Vikas Dikshit, AVP New Product, Reliance Jio, but today representing actually a delegate of ORAN Alliance, and we'll hear how and what is happening in the ORAN Alliance to make the next generation technology. Over to you, Vikas. Thank you.
Yeah, thank you. I know it's the tea time, but I try to make my presentation as light as possible so that you will enjoy what I'm trying to say. So myself, Vikas Dikshit, I'm working with Reliance Jio as AVP, and I represent a standard organization. ORAN Alliance is one of them, which is very close to me. So I am sure that most of you know about the ORAN Alliance, but there are some of those which are not aware of the ORAN Alliance. I will try to brief you about that. So my agenda for today is that we'll talk about the ORAN Alliance, and within the ORAN Alliance there's a new initiative started last year, very early into the phase at this point of time, called NGRG, Next Generation of the Network, which is focusing on the 6G and beyond within the ORAN organization, and which are the current stream ongoing at this point of time, where we are and what we are looking forward within the ORAN for the next generation of the network. Since we are talking about the 6G and beyond,
So I try to focus more on the NGRG aspects in my presentation today. So what is O stands for in ORAN is open. Why do we need openness? Openness is needed for many purposes. So one of the main drivers of the ORAN is to make a very big problem into the smaller problems and target to solve those small problems in a specified manner. So we heard a lot about the money aspects of the systems, that it requires a lot of money to build a system, and also there was yesterday some CA was also there, and he spoken about that how do we monetize the money and other aspects. So that is other aspects, and before that we need to think that how do we bring down the cost of the network deployment. So one way of doing that is to break the big problem into the smaller problems and have generic solutions for those. Like, for example, we all wear clothes. So what do we do to bring down the cost? We stop buying the designer clothes, which are very expensive, meant for a specific purpose. But we buy T-shirts, which is produced in the masses to bring down the cost. And the similar analogy starts have the same thing within the ORAN also, that we have all those specialized solutions which works in 2G, which works in 3G, but then we start seeing the changes from 4G onwards, and then 5G and going beyond, that we don't want to have one solution existing, and that go for a very long period of time before we take another solutions. So in terms that we have to buy both the hardware and the software from a particular vendor, and it serves its purpose for its life. And then we have to rip and replace the whole of the things. And that's where the ORAN comes into the picture, that it tries to, okay, let me go through that why and from where it has been started. So ORAN Alliance is very new in terms of the SDO life. So it started somewhere around 2016 with Professor Sachin Katti, is the professor in Stanford University, in association with AT&T, DT, and SK Telecom, the XRAN forum. So the initial idea behind is that, can we take a brain out of the RAN and put it somewhere else and customize that brain to suit a particular need? To give you an example further, that if somebody asks me that what is a ORAN in one word, I try to explain them that what the Android has done to the mobile side around a decade before, the ORAN and the ORAN system and ORAN Alliance is trying the same in the RAN side of it. So the idea behind is that you have a system which is customizable for a particular need. And then the China is also doing something in the same domain, but in the mostly in the cloud side of it. And both of them merged together, XRAN and CRAN, and they formed the ORAN Alliance in 2018. So this is around 5 years before, and not before. So, but within this short period of time, we have, this organization has grown a lot. So I have recently taken this number. So there are 324 active companies, universities, government bodies, vendors, operators. So this is grown a very big organization in such a small period of time. So idea behind is that the many companies and others are interested into this because it's trying to change something which is generic and also bringing down the costs of the network by having a very big problem into the smaller problems and the problems which can be solved in a generic manner. Okay? And there are around 2,000 delegates from different organizations which regularly participate into the ORAN. I personally associated in ORAN Alliance from 2019 onward. So since the beginning of the ORAN Alliance, I represent around 7 working groups and lead NGRG Research Stream 1, which is typically targeted to the use case and the gap analysis. So we are speaking about, we heard about the contributions from India and the contributions that is going. So I can say that I go to these standard bodies and there are, apart from the delegates, the Indian contributions is going further and further, and there are more and more, irrespective of which companies they are working for, but there is a lot of contributions coming from India, and that is very good sign for us to see that we are doing a lot of contribution into the standard bodies, and this community is strong day by day, and we expect to see more in the future. So I will spend few slides on ORAN before I will speak more about the NGRG initiative within the ORAN to set the context. So what is the ORAN? So ORAN, we see that so what is the purpose of the ORAN? So the purpose of the ORAN is that we want to create a competitive and vibrant RAN supply system and a faster innovation to improve the user experience. Okay. So how the ORAN is doing that? They have basically the 3 main streams, the specification part of it, and to brief you about this, that 3GPP is doing the standardization effort. We all know that they are doing it from many, many years. So idea behind ORAN standardization is not to compete with 3GPP standard, but collaborate and to work in the areas where the 3GPP does not work. For example, one of the interface that the ORAN Alliance has taken up is the interface between the DU and the RU. So that is, we call the front haul interface. So idea behind that interface, whatever goes on the tower, we want to minimize that, and the rest of the things we can put it at the central server where it can be run as a software. So it brings the 2 advantages. So we segregate hardware from the software. So, and we use the general purpose hardware in the terms that we use the COT servers and run RAN applications as one of the software component onto that hardware. So as I explained previously, that in 2G and 3G time frame, we have to buy one thing from one vendor and we kind of marry to them. But the problem arises that we want to implement a new feature. So it takes a very long time to introduce new features. So, but the ORAN Alliance is trying to solve that problem by taking out the brain out of the system and using that as the accepts and RFs. So that when we require a new features for our purpose, we can do that very easily. So, but that has to work on any system. That is where the standardization effort is going on in the ORAN Alliance, which will do the specification part of it. There are many working groups. I will go through in my next slides that which are the working groups within the ORAN Alliance. And the second part of it is the software community. So ORAN Alliance has a very strong software community. They are building the software and it is under the Linux license, so it's kind of free for all the experimental uses and things like that. So idea behind is that we want to make those software as low cost as possible to bring down the cost of the whole system. And also there is a test bed where people can go and test their applications before it can go into the commercial market. And the third one is the test and the integration efforts. There are specific OTEC labs all over the world where the people can go and test their equipment and basically for both conformance as well as the interoperability. So there are test cases for those so that one system will work with the another system. So it is like you take your mobile nowadays, it works everywhere in the world. The similar things is happening at the RAN side also. If you build an RU, that RU has to work with any of the DU. And that is the motive behind to bring down the cost, that you build it for everyone, not for a particular person or a need or a system. This is the architecture of the ORAN Alliance from ORAN Alliance. So as I mentioned, so we are trying to, so previously this all used to be one block where you have the CU and the DU and RU and everything was inside one box. And you have certain controls in terms of what you can configure, but you can do only the things which is provided by one solution. So first thing that the ORAN has done is to split the big problem into the smaller problems, as you can see. And then also you see there is in the down there is a O cloud part. So what is for that means is that you run the software in any hardware. So and that's where we see a lot of interest and lot of more players are coming in the ORAN Alliance. Either they are from the hypervisors or from the cloud community or from the smaller companies which are expertise into a particular domain. And the trend nowadays that we also see, which is going to be a new thing, is that there are companies which will only focus on the RFs and the accepts. So it means that you buy a system from one company and then you run accepts and RFs from the different companies. So that will bring the innovation into the RAN side of it. Like for example, in India we use Ola, Uber, and we have all the apps in our system. But if we go to other part of the system of the world, there are same kind of things, but let's say Grab is more used in Malaysia and Singapore. But they all work in your phone. So the similar things is what Accept is doing is that we have a specific need. We will solve that need using the Accepts and the RFs. And that will be deployed on top of the near real-time RIC and the non-real-time RIC that you see. That will bring down the cost and also innovate in the future. So that is the purpose behind the ORAN Alliance. There are many working groups in the ORAN Alliance for that. Working group 1 is for the use case and the overall architecture. Working group 2 is for the non-real-time RIC. Working group 3 is the near real-time RIC. Working group 4 mainly focuses on the specification between the DU and the RU. We have working group 6 works on the cloudifications. Working group 7, white box hardware. Working group 8 is tech reference design. Working group 9 is open XHAL transport working group. And working group 10, which focuses on the O&M aspects of the system. And working group 11 is the security. So we can spend a lot of time on this slide, but I want to have my focus on the NG overview and also what's going on within the ORAN Alliance for the next generation of the network. And that is what we are discussing in this conference, is mostly related to how do we look forward. So, the mission of NGRG is to facilitate the 6G research efforts and publish research findings. And then also leverage the industry and academia 6G efforts. Achieve ORAN sustainability from 5G going on to the 6G, and also partnering with the different SDOs all over the world. There are, how do we operate that? We have a research agenda and the key priorities. There are research streams that already been established, and some of them are still in pipeline. We organize regular discussions in this effort, and also interwork with the ORAN solutions. What will be the outcome? Outcome at this point of time from NGRG will be in terms of the white papers and the research reports, and take the appropriate actions using those white papers, and sponsor workshops, seminars, and summit. In terms of the roadmap, it has been divided into 3 parts: the near terms, mid-terms, and long terms. And near term, which is started from last year to 2025, will align with the industry partner. We heard a lot about these in previous sessions, that which are the companies and the industries are working in this. So near terms objective is to align with those industry partner. Midterms is to provide input to the ORAN working group and the focus groups, and also coordinate the 6G collaborations with other SDOs. In long terms, the specification will be written for the 6G and also giving input to the other SDOs via LS. Research topics, there are many of those. In the constraint of time, we have heard this in many of the previous sessions. I will not go through the details about this. Research streams, which has been in discussion at this point of time within the ORAN Alliance, is related to the requirement, architecture, management, security, AI, cross-domain AI, and also the sustainability that we heard a lot during past 2 days. The current RSS which is active is 5 at the moment. The first one is related to the use cases and standard gap analysis, which I am co-leading with the others in this domain, and also the architecture of the ORAN, which is going to be changed for the 6G and next generations. Native AI and cross-domain AI cannot be separated in the next generation of the network, so there is a specific research streams for the native AI, and also for the security is another aspects which has to be dealt very carefully going forward. So one dedicated research stream for security, and another one is for the platforms. And what is ongoing at this point of time? 5 research streams are in place, 7 research items ongoing. First wave of white paper is coming this year in June, covering the use cases requirement, AI-related architecture, and we have trying to establish the strong partnership with global 6G industries. And there are many workshops that has happened during the face-to-face meeting, last 2 face-to-face meeting. First was in October, and second was in Feb, and there is going to be one more in June. So that's all in the constraint of time. I was not able to focus too much, but I hope it's useful for everyone. Thank you.
Thank you, Vikas, for giving a good insight on what ORAN is doing. So with that, we come to the conclusion of this panel. Over to you, Shashi.
Yeah, long panel. We are running almost 40 minutes late. So we started our morning late, so that we are continuing late. So do you guys want a 10 minutes break? Yeah? So we need to come back in 10 minutes, because the next session we need to start at least by 12:45 at least. Huh? So I request the chair to present the mementos. First to Amit. We have tea served in both the halls. Huh? So some can go to the next hall where there is an exhibition. There also it is served. Chip Stephen. Sadav Siddiqui. Mahesh. Then to Vikas. May I request Mr. Robert Ravi to come and present the memento to the chair. The chair. Thank you. We'll have a group photo.